right here, aren't I?
Yeah.
Now I am 3, 4, 5, 6.6 is about here. That Earth looks pretty small here. I can see it's a little round ball, and I can almost see half of the thing, right? So one satellite can actually hit almost an entire hemisphere of the Earth, right? Now, to be sure, there are not very many satellites right here. I'm right above the Pacific Ocean. Not very many satellites here because nobody really has the money to put up satellites for all those little islands. There are some probably that can see it, right? There's a ton. If you look at the map of where all those satellites are, there's a ton sitting right here above North America. And then Eurasia, right? You can see all of Eurasia from here. It's like, ooh, there's a ton up here. The funny thing is this, right? So when you look at where the satellites are, there's the low satellites. Those are the spy satellites. Typically they're in like polar orbits, so they can sweep off a little bit of different part of the Earth every time, right? Okay, those are the spy. There's also low Earth equatorial satellites called the Iridium array, which was supposed to be like a cell phone thing, right? Because cell phones obviously can't reach something out here, okay? You don't want to put something next to your brain that can send a signal all the way out here, right? Pretty sure that's going to give you cancer. We're not sure about cell phones, right? Okay, so there's low Earth satellites that are like either close-in communication or spy satellites, right? Then pretty much there's nothing in between, and then out here, chock-a-block on that thing, and this thing is actually just a ring. This geostationary orbit is just like the equator, only it's 6.6 times the radius, right? It's out here. This is chock-a-block. There's just satellite. Everybody's got them out here because those are the most useful ones, right? Now, if you look close, if you zoom in on that ring and look at it, there's some satellites are a little farther out, and some are a little closer in. Those satellites, by the way, are not geostationary. What are they? Everybody know? Those are the dead satellites. Satellites only live so long, and when they die, they just boost them out of the way and then put the new satellite back where the old one was, right? So they've got all these like other satellites, and they're out here. There's basically no atmosphere, and they'll just stay out there forever, pretty much, right? Solar winds and stuff might make them tumble and stuff like that. So if there's a solar flare, but you know, there it is.
They wanted to build a space elevator. Wouldn't that just be like having a magnet spin above everything?
Yeah, space elevator idea is that you get some sort of cable that's got the tensile strength, and then you just stick a mass out here, and the centrifugal force, we'll use the F word, keeps the cable taut, right? And you can imagine that there's got to be some speed where that works, some configuration, right? And then instead of using like all this fuel and stuff to climb it, you just have a solar powered thing that just creeps up that cable, right? That's the idea. Yeah, you wouldn't want to take a meteor hit on that thing, right? Okay, we've already done velocity, so let's try this one. At what distance from the moon's center is the orbital velocity 52.5 meters per second? So which condition do you want to use? The mv squared over r1 or the m4 pi squared r over t squared one?
That first one.
Yeah, the first one, the mv squared. And you want to solve that for what? What are you going to solve it for? R, there you go. So the first thing I want you to do is solve that condition for what r is. That's what you are going to do. So solve this expression, mass of the satellite, v squared over r, equals g, mass of the central body, mass of the satellite, over r squared. Solve that for r. R equals what? Algebraically, I don't want a number, I just want an algebraic solution. Then I want you to plug numbers into it, okay? Show me the solution on a whiteboard.
Wait, algebraically or the actual?
I want the algebraic solution. Yeah, that's right. That's right. Plug numbers into that now.